we looked into an effect that at the time was not that explored on magnetism, which was called the magnetocaloric effect. So an effect that happens on magnetic materials, that you can cool them and heat them and do thermal cycles with them. So we started our work on magnetocaloric effect by looking into issues that were more fundamental. So the magnetocaloric effect is a complex effect because it has magnetism and heat exchange and phase transitions and complex phenomena. But the more we worked on the more theoretical and concept side of things, we noticed that there was an application methodology that could work, which was the rotating magnetocaloric effect by this demagnetizing field. So on the laboratory, our first concern was really to check if this effect actually happened or not, because there was a big discussion on the team. So this is research with colleagues, mainly with colleagues in Porto. We were never 100% sure that this effect was actually true. So we idealized that it should happen, but we had no idea on how intense or how useful the effect could be. So the first thing we did was to verify it. And we actually did two different experiments, one here at CICECO, another at Porto University, and like double blind in a sense. So they did their measurements, we did ours, and in the end we checked if they matched or not. And luckily they did, so the effect is true, and that led into the publications and the funding that we eventually had. The idea that we had was using this highly efficient refrigeration method for vaccines. So this was actually a successful Pathfinder application with colleagues from Porto and colleagues from Slovenia, England, Spain, etc., where we are hoping to use this demagnetizing effect to cool down vaccines in the last mile of vaccine distribution in, let's say, in desolate regions where you don't have power supplies until the last mile.